Hello friends, welcome to a new video of the Java online course. Now in this video we are going to talk about the Java's collection framework. Very interesting data structure collection and algorithm collections are available in Java programming language in some of the packages like java.io and java.util. With the help of this particular collection framework, we can do so many operations so much easily, effectively while creating any Java application oriented project. Collection framework, what do you mean by this? So Java has provided ad hoc classes such as dictionary, vector, stack, properties to store and manipulate groups of objects. Although these classes were quite useful, they lacked a central unifying theme. Thus the way you use vector is different from the way that you use the properties. They are having connectivity with them, but you need a practice to make the connectivity among all of these classes. The collection framework designed to meet several goals, such as the framework had to be high performance, implementation for the fundamental collections like dynamic array, linked list, trees, hash tables were to be highly efficient. The framework had to allow different type of collections to work in similar manner with a high degree of interoperability. The framework had to extend and or adapt a collection easily. Okay, so what it contains actually? So three common and basic things that collection framework contains. First, interfaces, second, classes, and third, algorithms. Interfaces. These are the abstract data types that represent the collections. Interfaces allow collections to be manipulated independently of the details of their representation. In object-oriented languages, interfaces generally form a hierarchy. Second, implementation, that is classes. Many classes are there, concrete implementation of the collection interfaces. In a sense, they are usable, reusable data structures. They are available in the form of a class in collection framework. And the third, algorithms, default inbuilt algorithms of data structures, just like searching, sorting, ordering, all kind of elements or algorithms are available. The algorithms are said to be polymorphic, that is, same method can be used on many different implementation of appropriate collection interface. Make sure that you need to note down this line. They are polymorphic. Many methods are available to almost many collection data structures. Okay, so if you see single data structures, a similar kind of method are applicable to almost all kind of data structures also. You can practice that and find the perfect utilization and application of this concept. Let's start with the interfaces first. Basically, it contains many interfaces, but out of all, some of the commonly used interfaces and their application I'll show in this video. Let's start with the first, that's called as list. So list interface extend the collection and declares the behavior of collection that store the sequence of elements. So list is the sequence of elements. Any sort of sequence of elements can be created with the form of a list. List interface is implemented by many different data structure classes. So they contain common ability that list interface is containing. The list may contain duplicate elements. In addition to the methods defined by the collection, list defines some of its own. Now it may throw unsupported operation exception, or it may throw class cast exception also. Now let's see the example of the list. Now so list is an interface. Directly their object is not possible, but the class who implements that list interface, their object we can assign to the variable of the respective interface. So let's see. First of all, in this particular program, I have created the object of array list class who implement the list interface there. So array list is just like an array, but it is dynamic array. So it's a list of element can be created, can be added inside it. So let's see this. A1 is a list created of type array list. So array list class has implemented the list interface. That's why we can assign that object to A1. Now in this list I am adding Ajay, Manoj, Deshpande. So A1.add, A1.add, A1.add. So three elements I am adding. Dynamically any such number of elements we can add inside it, and at a time the complete list can be printed, which is not possible for the array, common simple array type of the data. But as this is the object, I can directly print this object on the screen by this particular method. Okay, after that I'm going to show a separate list again, linked list. So linked list is also implementing the list interface. That's why I can assign to L1. Now in this I'm adding three elements, Mahesh, Raghav, Patil. Okay, so three elements, first Mahesh, second Raghav, third is Patil. Okay, and after that I'm printing this linked list element directly on the screen. So this is what add method is. add method can add the element to the list, and that can be printed on the screen in this way. See this is a list of elements created. So 3 elements are stored inside it. They are just like array, but array processing is like array static kind of data structure, but list and linked list, all the list elements are dynamic data structures where n number of elements can be added. They can be used to perform separate different operations onto it. If you just type a1 here, check it out, a1 dot, so we'll list all the methods which we can use along with it. Now the methods which are shown here, like add all, get or isEmpty, iterator, okay, remove, set, sort, this method directly we can use. Okay, so the method which are shown in the black color, it belongs to its own class, and which are shown in the which are not bold, actually they are taken from some other classes. Okay, and the return types are also shown over here. So out of it I showed only add method, which I can add the data inside it, and that a data structure of array list and linked list is formed. So those who are implemented the list interface here. Now let's go for the second type of interface, that is called as set interface. Set interface, set is a collection that cannot contain duplicate elements in it. It models the mathematical set abstraction. The set interface contains only methods inherited from collection and add the restriction that duplicate elements are prohibited. See, that's the main property that set is containing. Duplicate elements are prohibited. Single copy is considered a single copy. 10 copies also considered as single copy. Okay. So set also adds stronger contract on behavior of equals and hash code operations, allowing set instances to be compared meaningfully even if their implementation type differs. So let's use this set now. So the classes which implement the set interface, so I'm using two classes here, hash set and tree set. Okay, so first of all let's declare the count. So some 8 elements are declared inside this count array. Okay, and then I have created this set. So here I'm using a generic class, set of integer numbers. Okay, so set of integer number is formed here. Parameter or the object name is set, and new hash set I have created, and with the help of the add method I'm adding the elements inside it. The main prime application of set is it contains the collection of elements without duplication. So let's see this, what I have done here. Okay, so 34, 22, 10, 60, 30, 22, 34, 56. You just can see these two elements are duplicated. As you add the elements, duplicate elements are not having any existence inside the set. So duplicate element will be removed. So when you print this data on the screen here, after elements are added by the for loop, if you print them, check the output whether they are generating actual results or not. Now one more set I am creating here, it's called as a tree set. This name I have given as sorted set. Okay, so tree set, this particular set is the sorted set. Means when you save the data inside it, data will be duplication will be removed, and data will be stored in the sorted format. That's why I've given the name as sorted set, and its data type, its object should be of tree set. Okay, so let's see this. I'm printing this set on the screen. When you convert that data, this particular set, in the form of the sorted set. Okay, that's what I have created here. This parameter I have passed, this one I have passed over here, and that's converted in the form of sorted set and then printing it on the screen. Okay, and let's demonstrate the use of some methods here. First method I'm using here is first element of set, sorted set first element dot first. It will access the first element in the sequence, and dot last will access the last element in the sequence. Okay, so this is how we can add the elements, and we can access or retrieve the elements from the respective set is. See this. So first of all, when I run this, check it out, this and this. So here duplicate elements are removed. The duplicate elements were 32 and 34, they are removed from here. See this. Okay, and so they are added. After that I have converted into tree set format. So tree set is this. So tree set will store the data in sorted fashion. So next, check it out, all the data is sorted, duplications are removed. So when you have to store the data in this particular method, we need to create the object of type tree set. Okay, and now first element from the tree set, this I have printed here, that's the 10 here, and last element is 60 that I can access here. Okay, so this is how these set operations will work. And if you want to see the methods of the set, so you can just make use of this set dot and check out the methods. The bold method belongs to its own class. To remove, contains, or clear, add all, is empty. These methods we can directly apply. to array, size, splitter. Okay, these are the commonly used methods that I can apply on this particular set structure. So set interface is to store the data in unique format or in distinct values only can be stored inside this kind of the data. Third interface is a map. Map interface maps unique keys to the values. The key is an object that you use to retrieve value at later date. Given a key value, you can store value in a map object. After value is stored, you can retrieve it using key. Consider an array. Array, if you want to access the array, we use the index values there. Index are unique. Remember, if I'm using index number 5, so 5 is unique throughout the all indices. Now this index is called as key and the value present over that index is called as value. So this concept is called as key value pair, and if you want to use key and value all together in a data structure, we will be making use of the concept called as interface map. If you are knowing Python, in Python dictionary concept was there, and even in Java programming language also the previous versions of Java was using dictionary. Now dictionary is not available. Dictionary was containing the concept of key value pairs. With the help of that, key and value can be stored in an object. So let's see how map interface will work. Okay, so for map I'm using a hash map here. Let's see how these hash map elements are used. So I'm creating hash map m1 is equal to new hash map. So make sure that all they are defined into utility package here, all collection interfaces. Map m1 new hash map. So hash map class I'm creating, and m1 is the interface reference variable. Now interface reference variable contains the method called as put, by which you can add the data in the form of a key value pair inside the map. Okay, so how to add that? See, m1 dot put Radha 8. So Radha is the key and 8 is the value. Praveen is the key, 31 is the value. Arjun is the key, 12 is the value. Pramod is the key, 14 is the value. So in this way we can put the element inside the map. Okay, so yeah, I'm using hash map. I'm entering it, then I'm using a new line. After that I'm printing this map element on the screen. Once the elements are added, these elements are printed on the screen directly by printing m1 object here. So when I print it, check it out how these key value pairs are stored in the form of a map. This is what we call as hash map. Hash maps are represented, actually all maps are represented with curly braces. These values are stored in the curly brace format. Dictionary was also containing similar kind of method and mechanism to store the data within it. So Pramod 14, Arjun 12, Praveen 31, Radha 8. So see, sequence is different here. What sequence we have used, that sequence is different. So Radha is here, then Praveen, then Arjun, and then Pramod. So in this sequence they are added. This is what we call as the map. Key and key value pairs can be stored in the form of a map. Okay, so this is what also referred as the dictionary concept. Okay, and the fourth last interface, that is enumeration interface. The enumeration interface defines the method by which you can enumerate, that is obtaining one element at a time, the elements in the collection of objects. This legacy interface has been superseded by iterator. Iterator and enumerator, they are almost working in the same direction, but iterator is now deprecated. Enumeration is considered obsolete for a new code. However, it is used by several methods defined by the legacy classes such as vector and properties used by other API classes also. It's currently in widespread use in the application code. So let's see what is the meaning of enumerations. Yes. Now let's create one object here. So I'm creating a vector object. Vector, just consider vector is a dynamic array of different kind of the objects. So we'll come back to this point again, vector. But to demonstrate enumeration, I need to create a vector. So in this vector is just like an array of objects. So in this vector I am adding some numbers. So vector I have created here, dot add Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. Total 7 elements I have added into this particular vector. And now these all elements I am storing, so let's see, day names dot elements, all these elements I am storing to enumeration days. See, enumeration days. Now when I am storing it in the form of the enumeration, then what happens? It will contain ability to get iterated one by one with the help of the methods of enumerations. What method it has? The method I am using over here is has more elements. Days dot has more elements. Now what it returns? It returns true if that days contains more elements inside it. Yes, it is present. So first of all, enumeration will point to the first element in the collection, in the vector. So first element is present, yes. So access it. Days.next element will access that element, and by using system.out.println, I am printing it on the screen. Okay, so what it will do, it will print the first element Sunday and will move the iterator or the enumerator to the second element, that is will go to Monday. Again true, print it. Again Tuesday, again Wednesday, Thursday, Friday, Saturday, and then pointer will be moved at the end of this particular list. Now has more elements will return false. It means that now the collection element has completed and the operation now onwards can't be performed. So this is how, by using this elements has more elements, I can identify whether more elements are present in the collection, and by using next element I can access one by one element from the respective data collection. So if I want to see the methods from this, see, so I can just find, see, only two methods it belongs, has more elements and next element. With the help of these two methods I can iterate through the collection of elements. That collection element should be present, should be stored into the enumeration element, and then by using this method I can go ahead one by one. So if I run this code, check this, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay, so iteration through the elements is possible with the help of enumeration interface. So it's acting one of the most important concept here. Most of the time in advanced Java technology also, when collection of elements are created and we have to iterate through all these collection element, this enumerator forms a very important concept, important facility by which you can iterate through all the elements from these respective collection elements. You just try this. After this video is over, you just can try enumerator to remaining other elements also. Okay, so four commonly used interfaces are used inside the collection interface. Now let's go for the second part, that is classes. Now if you are already aware about the data structures, okay, so these data structures store the data in different format. Based on that format, they are having different properties, they are having different methods, and as per the requirement of the user can choose the way to store this data. Either we can use linked list, we can use queue, we can use stack, we can use graph, trees. So these data structures can be used to store the data in different ways. Out of it, very commonly used data structure are the linked list and the stack. So let's see what linked list is. I'll just revise the concept. If you're already knowing it, it's no worry. Here linked list is just like a dynamic array. Okay, so array elements are stored in it, but these elements are not sequentially ordered. Means the elements are not stored in the sequential order inside the memory. They are stored, but they are connected by a pointer variable. Now this is single element, that element contains the value and it contains a pointer and location which point to the next memory address B. It also contains a pointer for the next memory address C. It will contain a pointer to the next memory address, and at the end it will contain a null. Okay, so elements are connected together, but they don't follow any contiguous order. That is the first property. And second property is n number of elements are added. Means the linked list is always a dynamic. Any number of elements we can add to the linked list. Okay, so now if we want to create this linked list, so linked list implements the list interface. So linked list is a class where these elements can be added. Now let's see how to create a linked list. So here I created a linked list and I have demonstrated some methods of the linked list over here. How to do? So LL, this is the object which I have created, linked list, and after that by using add method, as we have already seen in the list interface, LL add F, B, D, E, C, they are added. And if I, for example, I want to add element at the last, so it will add Z. I want to add element at first, so I am adding add first A. Okay, and if I want to add element at location number 1, I'll add and location and the value that you have to specify. So in this way, add method and add last, add first method will work. After that, I'll print the collection of this particular data, linked list on the screen. Dynamic, so that's why add method will directly get applied and it will print the list on the screen by this particular mechanism. Now, if I want to remove the elements, so let's see, ll.remove F. So wherever the F is present, that F will be removed from this. Okay, if I want to remove the location number by location number, so index number 2 data will be removed by this particular method. So after deletion, again I am printing this it on the screen. So 2 elements I have removed from here. How to use remove, check it out. And after that, I am using 2 more methods, remove first and remove last. So the default first value which is present inside the linked list, and then the last value present inside the linked list will be removed with the help of these 2 methods. Okay, and after that I am printing it on the screen. Fine. And then last, so I want to get object present at location number 2. So what, after all operation, what's present at number 2 from starting from 0, 1 and 2, so that will be extracted. Okay, and I'll be putting some value, string value changed there. So ll dot set, at second parameter I am storing the same value, but it will contain changed connected to it. Okay, like this, val, string value of val, typecasted that value object parameter to the val plus changed, so it will contain that value changed, 3 change, 10 change, something like this. Okay, and after that at the end I am printing this list, linked list on the screen. Okay, that's how the linked list can be created. It is dynamic, so any number of elements are added and any number of elements can be removed from the respective linked list. There, if you run this code, see the previous list where I have added, created a list, and then A2 and A were added here. See, this is add last, add first and add 1 here. After deletion, so which elements we have deleted here? F and 2. So F and 2 I have deleted. 2 means second element, that is it was F, sorry, F and 2, it was containing B there. After deleting F, B will come here and that will also get deleted. Okay, then remove first and last, so A and Z are removed, remaining are available. And here I have extracted E. Okay, E is extracted and added. To that E I have added changed, so E change, it is added here. So after the last change I am getting the output something like this on the screen. Okay, so this is how we generate the result. We are going to perform operation with the help of a linked list. So linked list dynamic data structure can be created by the collection class called as linked list. So program is given to you, you just can make the changes inside it, create the list accordingly your ideas and see the output. Now second is the array list. Array list, it is extending or it is inheriting the array list class and implement the list interface. It supports dynamic array that can grow as needed. But see, one important thing here is that array list is the collection of elements stored in sequential order, contiguous memory location, but linked list is not. Standard Java array are of fixed length. After the arrays are created, they cannot grow or shrink, which means that you must know in advance how many elements in array will hold. Array lists are created with initial size. When this size is exceeded, collection is automatically enlarged. When objects are removed, the array may be shrunk. Okay, that is what dynamic data structure array list is. So let's see how to use array list. See, so here AL is the array list object I have formed. Then initial size, I want to see the size of it. So it's just like array. Okay, so dynamic array, and if you compare that with the list, linked list doesn't store data in contiguous memory locations, but array list can store. Okay, so size, initial size of it, that will be printed here. Let's see what size it will contain. Now after that I have added 6 elements inside it, C, A, E, B, D, F, and at location number 1 I am adding A1. After that what size it contains, that I will show. Dynamic size growth. Then contains, I am showing after this. Okay, and I want to remove the element F from there, or location number 2 element from there. So you can remove by this method and mechanism. So when they are really deleted, check the size and check the contents of it. Okay, so this is how the array list can be created. So if I run this code, check this. Initial size is 0, means nothing is present inside it. After addition of 7 elements here, I have seen the value has changed to 7, and then the contents are printed on the screen like this. When I have deleted 2 elements after that, so size become 5 and the elements are something like this. Okay, fine. So array list, an array contains the property that array list does not require the number of element to be declared when you declare the array list. And if you compare that with the linked list, here elements are not contiguous memory location, and in linked list elements are not stored in the contiguous memory location, they are randomly stored inside the memory. Okay, now hash set. Hash set is the implementation of the set interface. It extends the abstract set and implement the set interface. It creates a collection that uses a hash table for storage. Hash table store the information by using a mechanism called as hashing. It's a part of data structures. So in hashing, the informational content of a key is used to determine the unique value called as the hash code. The hash code is then used to is at the index at which the data associated with the key is stored. The transformation of key into its hash code is performed automatically. So let's see how to use the hash set. So it's very simple to show that. Directly I'm creating a hash set object, and then I'm storing these values inside it and printing it on the screen, hash set. So as the property of set is that it does not allow duplicate element to be stored in it. So when I run this code, check it out, I just added the elements A, B, C, D, E, F. Okay, they are stored in the sequential order here. And if I make this element as E, check the output, see A, B, C, D, E, but E is duplicated, so it's not stored in it. If I make this D, A, B, D, E, only they are stored. That is what the property of hash set is. But it contains one method. If you want to search the element inside the set, in hash set, it provides the mechanism of hashing. By this mechanism of hashing, element access will become simple for us. Okay, so that's what the main property that hash set is containing here. And method to add the element inside it, they are also almost same that we have seen already for the remaining data structures. Okay, and then it comes with the last data structure called as tree set. Okay, tree set provides an implementation of set interface to use the tree for storage. The data is stored in the form of a tree. You might have seen the trees in data structures. Okay, that these objects are stored in the sorted and ascending order. Access and retrieval times are quite fast, which makes tree set an excellent choice when storing large amount of the sorted information that must be found quickly. That's why tree set is preferred. Okay, sorted data is stored, and advantage of sorted data is searching the data inside this particular data structure has become more and more simple than any other kind of the data. That's why tree set forms one of the most useful and implementable data structure to store the data elements within it. We have already seen this algorithm in set, but I'll separately show you this one. Check it out. Okay, TS, and then these elements are added, and I'm printing it. See this. And this is also set. That's why if you duplicate the element, it will represent only one number of time, and they are always in sorted form. Always. See the methods that I can use are this. I can use iterator, comparator, clear, add, first, see, then is empty, last, lower, remove all, size, see, subset, tail set, okay, all this. So these are the method that we can use along with the tree set here. Okay, so almost similar methods, not similar method, when you use it in program, hash set and tree set are almost used in the same way, but their internal data structures, internal storage pattern of tree set and hash set are completely different. Okay, now let's go with the next new and most important data structure of collection interface is the vector class. Already we have seen in one of the programs here, but let's understand what the meaning of vector. Vector implements a dynamic array. This is similar to array list, but two differences are there. Vector is synchronized, and vector contains many legacy methods that are not part of the collection framework. Vector is the collection of dissimilar data element. Dynamically we can store. Vector can contain elements are of different type. Vector proves to be very useful if you don't know the size of the array in advance, or you just need one that can change sizes over the lifetime of the program. Let's see exactly what vector is. Okay, now many methods that vector is containing by which you can perform operations. See, now I am creating a vector here, vector 3 and 2. 3 is the initial capacity, initial size of this particular vector, and 2 is the increment. Increment means when the number of elements, what size of vector grows. So when it overtakes the original size, then automatically the vector will grow by 2. Okay, 3 plus 2 plus 2 plus 2 plus 2. In this way the vector will grow and will take the elements inside it. So initial capacity I am printing here, initial size, that is will be 3, and check the capacity, initial capacity of it, how many elements can now be stored inside the V. Okay, after that I am adding the elements. Now one more important thing you have to remember, that add element method is used to add the individual element inside the vector, and that element can be of any object type. So here first of all I am using integer, I am using double afterwards, then I am using double, then I am using integers. Any such elements can be added. I can add string, I can add double, I can add short, byte, boolean, character, string. Okay, anything can be added inside the vector by using the method called as add element. So I am adding 1, 2, 3, 4 elements. After that I will show the capacity of this particular vector. So it is overtaking this 3. Okay, so 4 element I am adding. Fine. Then I am adding one more double, then see capacity, then again 2 elements are added, then I am seeing the capacity, V dot capacity, then float and integer I am adding, then I will see the capacity, yeah, correct. Then 11 and 12 again I am adding, and after that I am accessing the first element of the vector and the last element of the vector by using the first element method and the last element method there. So here in this vector I have added integer, float, double, and okay, only 3, so fine, integer, float, and double. Okay, in this way I can store the data inside the vector. Okay, now here if we contains integer 3, it contains method used to check whether any element is present inside this vector or not. If it is present, it will print vector contains 3. And now if I want to enumerate through the elements of the vectors, I can apply the enumeration interface here. So how to do? Enumeration venum is equal to v dot elements. So all the elements can be copied from the vector, and that can be stored to iterate or to enumerate with the help of the enumeration variable, that is venum. Okay, then by using the while loop I can iterate through it by using while venum dot has more elements. So it will go on true, 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 true till all elements are not over, and I am going to print these elements on the screen by using venum dot next element, and then keeping a space after that, printing it one by one. At the end I will have a new line here. Okay, so this is how we are going to make use of the vector. I will just show the output, they will discuss about that. So initial capacity, initial size is 0, then capacity is 3. Okay, capacity 3 elements are stored, size nothing is stored inside it. After 4 additions, it is becoming 5. So 3 plus 2. Okay, 4 elements are added, it's overtaking 3. That's why 2 are added, it becomes 5. Then I'm adding again 2, again 2, again 2. See this 2. Okay, they are added, and first element was 1, last element was 12 here. This is first element, last element was 12, and first element you added was 1. Okay, vectors containing 3, yes, contains 3, yes, it's printing this. And by using iterator, I am iterating all the elements, whether this is integer, whether it is float, or it is an double. Okay, or I can add the string element also. Check it out. I just here I am adding the integer, so let's add the string. Hello. Okay, just a minute. Okay, so here I am performing the operation of integer there, so it's not required because typecasting is not expected there. Yeah, see, so hello is also there inside it. What property that vector contains? So vector is a growable data structure. It can store all kind of the data elements inside it. All objects can be stored and can be retrieved dynamically. It can grow. It can have n number of elements stored inside it, just like array, list, but here dissimilar data types are allowed. That's called as a vector. And then come with the stack. So stack is a subclass of vector. that implements the standard LIFO type of data structure called as last in first out. Okay, stack only defines the default constructor which creates an empty stack and then includes the method defined by the vector and adds several of its own. See, you might be knowing the methods of the vector. See the methods of the vector here. So one simple stack I have created, then I have added, I am using two methods here, push and pop, by which I am adding the elements to this particular method. How to add that? See this. First of all, this is show push method I am using here. By using st.push, I am pushing this element to this particular vector, then printing this stack on the screen, and then second is show pop static method. To this I am accessing the last element st.pop. Okay, and printing it on the screen. That's it. That simple operation I have done over here. Now, first of all, I am pushing 42, then I am pushing 66, then I am pushing 99, then I am popping, again I am popping. Okay, and if the elements are not present, it will return empty stack exception, and that it will print the stack is empty. That's how. See, by using push and pop method, push method I will add the element to the stack, and by using pop method I can access the last element present over the stack. So the element which is stored on last will be taken first out with the help of pop method, and push method will is used to add the element to the stack. Okay, this is what we call as last in first out. The element which is stored last onto the stack will be taken first out of it, and then we can access, we can make use of it anywhere in the program or anywhere you require in your system. Okay, so in this way the stack works. You can try this system. So here I am using push and here I am using pop. These two methods I just using, and more effectively this is shown over here. Okay, now let's come with the last point of this particular video, is collection algorithm, the third part that the collection framework of Java programming language contains. A collection framework defines several algorithms that can be applied to the collection and maps. The algorithms are defined as static method within the collection class. Now, inside the collections class, we are having not many static methods by which we can perform different algorithms on the data structures. How to do this one? Let's see this. So, let's use a linked list, and on that linked list I am adding 4 elements, -8, 20, -20 and 8. Okay, now let's use first method, that is reverse order. So here I am using a comparator object R collections dot reverse order. So reverse order is used to order the elements in the reverse fashion. Okay, after that, by using these collections, by using sort method, I will perform operation of sorting in the reverse order. So this data, on this data I'll apply this algorithm. So I have declared the algorithm of comparator type of reverse order, and I want to apply sort this data in the reverse order that we can do with the help of this. Now let's check for the iterator. So from linked list I am creating an iterator elements. Iterator is created, and similar way that we are used for the enumerator, iterator can also be used. So how to do this one? The iterator element is this iterator dot has next and next. So has next is just like has more elements in enumerator, and next is just like next element in the enumerator. Okay, so till elements are not ended, it will go on using first, second, third, fourth, fifth onwards, and it will print them on the screen by this particular method. Okay, then I am using the new line, and now next one, shuffle. Shuffle is used to shuffle the data within the given list. So linked list, this LL is given as parameter to it, its element within it will be shuffled, and then that will be stored. Fine. And after the list is shuffled, again I am adding the iterator object to it. Li is the iterator object created here, and by using this iterator object I am printing this data on the screen, just like the one that we have seen for again enumerations. Okay, so iterator enumerations are almost work in the same way now, but iterators are not used much today. Enumerations are the very regularly used interfaces in many of the Java programs. Okay, now at the end we are using min and max. If you want to find the minimum element from the given collection data structure or maximum element from the given collection data structures, we will be using the min and max methods. So min contain the parameter of the list, and max also contain the parameter list. They are passed there. minimum number from the list and maximum number from the list can be printed there. One more important thing, I'll revise again. All these methods, collection static methods, are applicable to all the data structure that we have defined over here. See, if you type the collections dot, see, these are the methods that I can apply to almost all the collection interfaces. See, commonly used, see, commonly used are like copy, yeah, then empty set, fill, okay, then minimum, maximum, yeah, replace, reverse order, rotate, shuffle, sort, okay, and okay, these are the commonly used methods. Means some algorithm that we have to commonly apply on all the collection data structures, so that are specified indirectly as a static methods inside the collection object that we can see. Check the output of this particular code. The list in the reverse order is this, shuffled list like this, minimum is this, maximum is this. Okay, so in this way we are going to apply the algorithm, the default data algorithms to the collection elements and its data onto it. Okay, so this is what the collection framework that the Java programming language contains as per the requirement in the program to store the data, to retrieve the data, to perform the operations on the data. We can make use of these interfaces, classes, and the algorithms, the collection algorithms as per our requirement. So the things which are shown here in this particular video, these are the commonly used classes and interfaces and algorithms. Along with that, many more classes are there, but they are very rarely applied and used in the Java programming language. So programs about this particular video is also given along with this. You just practice it, change your data, perform operations, and if any queries are there, you can contact with us on the given mail IDs. Thank you. Thanks a lot.